Let's continue chapter 3.3 and looking at exponents. And so here's our first kind of description of exponents here as we think about multiplication as repeated addition, and division. Actually, we can view that as repeated subtraction, as we've done in previous videos. The concept of exponents, right, is used to simplify situations involving repeated multiplication. And so this is the notation we use here. You've seen this before, right? The way we speak to this here is a to the power of m, or a to the mth power. That's how we would say that. And you see we multiply the base with itself m times, right? They're m factors. So if this was a 5, that means we have 5 factors of a. And so that's the formal definition of a whole number exponent. And we make this distinction because some of you have learned that we can have other types of exponents, negative, 0, even decimal exponents, but that's for future discussions. And so a to the power m, again, or a to the mth power. And so what you also learn in algebra classes is these rules of exponent. And so you have these various rules. You have this one here. You have this one here where you add exponents because you're multiplying. And most people just memorize them and don't understand why we have those rules. They think they're just some made up rules, but they're not. But let's take a look at some of them. For example, 3.10 here, 2 to the power of 3 times 2 to the power of 4 is equal to 2 to the power of 7. And again, most students remember it's just I'm just going to take this and do 3 plus 4 and get 2 to the 7. Just like on this one here, you're going to do 3 to the 5 plus 7. And the reason you do that, again, is because you memorize the formula. You memorize this theorem here. It says just add exponents if the bases are the same. Now, it's important for you as future teachers to understand that 2 to the power of 3 times 2 to the power of 4 is 2 times 2 times 2. And then times 2 times 2 times 2, right, 4 times. And so then if you look here, you see there are 7 factors of 2. And so that's why the shortcut is just 2 to the power of 7. And it's important to also know that any shortcut in math has some, more than likely has some reason for that, right? And instead of writing the full multiplication out, we use a shortcut. But first we need to understand what that rule is. And so that's where theorem 3.1 comes into play here. And then you can see a proof and a formal proof. We won't do a lot of proofs in this class, but you'll see a formal proof of that. A to the m, right, times a to the n. You would put that m plus n factors. And so that's, remember, that exponent is the number of factors that we have. And so there's your proof for that. We also have this next theorem here, which is when you have the same exponent, your bases can be multiplied with each other. So you can see here, 2 to the power of 3 times 5 to the power of 3 would be the same as 2 times 5 to the power of 3, or 10 to the power of 3. Again, it's because of those exponents. If we wanted to show the work on that, again, looking at the proof kind of explains that out for you here. Looking at that proof here, a to the power of m, b to the power of, why is it equal to that? Well, we could write a out m times. We can write b out m times. And then you can put them together. Remember from associativity rules, or associativity rules of multiplication, you can then combine them. Since there are m factors, you can have m pairs, and so then that's where that rule comes from. So you can see that example there. And then we have an exponent raised to an exponent. And then we have that rule there, and then we use that to apply. The shortcut is to multiply them. And again, just to show you why the rule is just a shortcut, right? this means 5 to the power of 3 times 5 to the power of 3. That's what that means. So we've learned earlier then when you have the same base, you just multiply that. You just add those, right? So then you get 5 to the power of 6, which is the shortcut is just to multiply those two. And you can see it's been written out here. You can see where it's, but the shortcut would just be 8 times 4, 7 to the power of 32, looking at that. And then our last rule has to do with division here. And we look at the division here. The division rule is to subtract the exponents. And one reason, again, if you had 5 to the 7 over 5 to the 3, that's 5 7 times. And then what ends up happening is you end up, see how they match up? There's this one-to-one correspondence, and so that's what's really getting subtracted out. Oh, there's 5 of them. Oh no, 3 of them. 7 to the 3. And that should equal a 5, because what's left over is, sorry, not, jeez, I can't subtract 7 to the 4. 7 to the power of 4. Because there's leftover is 4 factors of 5. Oh, I'm messing this up. This is a, I'm looking at the wrong answer. Sorry, let's finish this up here. It's 5 to the power of 4. This one is 7 to the power of 3. This is 5 to the power of 4, which is what we matched up over here. Sorry about that. But you can see how that gets the shortcut is just to subtract. And so those are our rules of exponents.